Hello, Frontmania. It's amazing to be here. Yeah, it's my first time in this conference, and I'm loving it so far. And today we're here to talk about some not so popular web APIs focused in performance. And I'm really glad this section is actually following up the previous one because the previous one was really about web APIs which I know a lot. So I think they kind of match each other. So yeah, this is me. I am Matheus Albuquerque. You can find me everywhere as Y Combinator. I work with front-end at the company called Medallia, and I also mentor front-end students at Tech Labs, which is an NGO. Before we start, I do have a couple disclaimers. And the first one is that the idea for this session, and actually the title, is heavily inspired by a great session that I watched a couple years ago by Zeno. He was kind of exploring some new APIs in the HTML5 world and etc. when like HTML was news. And another disclaimer is I know that 45 minutes is a huge slot, so I will try my best not to bore you out with using memes and some demos. And last but not least, this is sort of a deep dive in some moments, so whenever you feel lost with an API or something, find this emoji. It means we'll have further discussions about that in the event. So a bit on the why I'm here and why we should care a couple of those things. I would like to start with an exercise. So let's go from stuff we probably don't know to stuff we already know and we are already doing. So we know about HTTP2, so we know about multiplexing, we know about the server push API and a lot of great things about HTTP2. We know that we should compress our JavaScript code. So we know that we can use gzip, but there are alternatives like Broadly or even zstandard by Facebook. So really good ways to compress our JavaScript. We know we should optimize the libraries we are using. So we can do that by replacing some of them, like Lodash has like lighter alternatives, or Malma.js, there's data FNS. So pretty much any library you're using, there should be like lighter versions. Or we can even update some of them. So if you're using React 15, when you go to React 16, you're gonna have like smaller bundle size. So many libraries, they do reduce the bundle size going from one version to another. And we can also, let's say we have some really heavy computation, something CPU bound happening on the main thread, we can offload that using web workers. So we know about that. We also know about bundle splitting. So if we have like a huge bundle that not only takes a lot to download, but also a lot to process in the browser, we can split it into smaller chunks. And by splitting, we can use dynamic imports. So we can have these bundles being downloaded only when the user actually needs them, for example, or we can come up with something that makes sense. So we are doing this, right? Yeah, the meme was, but yeah, we're doing this, right? So I don't know about you, but I constantly, even though like I know about these tricks and like a lot of performance optimization stuff we can do, I'm constantly facing like realities of our industry, and one of them is like when I was tracking the loading times and some other performance metrics from the app I'm working on. So for example, you can see like in the US and in Europe and some other parts, we had like good metrics. But in other countries, we had not really good metrics, and actually in some of them, we had like really poor performance. And this keeps bringing me back to this, that is like doing web performance is really simple, right? We just went through some steps that we should do, and then you just add something else, and your app is fast. So yeah, it was supposed to be funny. It worked. So that's why we are here, and that's what we're going to be discussing. So we covered the first part. Now we're going to talk a little bit about measuring, and also about measuring with the web APIs we have. And that's the first part. Once we measure, we also want to optimize. So we'll talk about optimizing with the platform. And last but not least, we'll reflect about why we are all here. So start about measuring. What does it mean for you to be fast? Like when someone says, okay, my web app is fast, what does it mean to you? Or do you want better? If you guys had to summarize web performance in one metric, what would you choose? For example, I don't know, loading time, responsiveness, I don't know. It's really important for me to hear from you, so I'd like to ask your help on this one. And I'm going to leave it like for 40 seconds, and I would like so much to hear from you that I'm going to give you stickers for those who answered. No, but seriously, I would love to hear your opinions, because this is going to be really helpful throughout the talk. So, which is also weird, right? Because 40 seconds sounds like really small time, but you have to keep finding topics to discuss in the meantime. But yeah, I think there's still some people scanning the QR code. So yeah, 10 seconds. And you'll understand why I'm doing this. But for now, cool. So for now, let's discuss some stuff. So we're always talking about load time, but there are other scenarios like this. So for example, that's a shopping cart. And this is not about loading, like the page loaded fast and everything was working, but this is about clicking a button and not getting a response. And by the way, what you see multiple times, there's even a name for that. It's called rage clicking. That is, when the user is so mad that something doesn't work that you keep clicking multiple times, hoping that it's going to make a difference, just like in an elevator. And this kind of things, it's so important and happens so often that we even have metrics to cover that. For example, first input delay. So, and yeah, again, this is like in real apps, and this is really happening. And this kind of thing, for example, happens when the main thread is blocked. So it turns out that a lot of metrics we have out there for like load metrics, they don't capture actual user experience. So it's important that we think about more metrics and things that capture more what really matters for the user. So we see, like, all of us are front-end engineers, and we like to brag about, oh, my app loads in n milliseconds or seconds or whatever. And the thing is, load metrics are not a single number. And back to the question that we had before, what would be your pick? Let's see your answer. So, I'm so glad it worked, like live stuff tends to fail. So, yeah, we have responsiveness, winning, then loading, time, UI, yeah, speed, Lighthouse. Yeah, I like Lighthouse. Cool. So if I were to list a few things regarding measurement or metrics, first we have what's called perceived load speed. So it's a loading metric, and that's basically how fast it can load and render everything to the screen, the visual elements. We also have load responsiveness that is really related, but this one is about running the code that is required for the component, for example, to be responsive. Then we have runtime responsiveness that is also tied to responsiveness, but it's about being able to quickly respond to user interaction, like the examples we saw before. And we have smoothness, so that's about animations and our transitions, like are they going fluidly, or what's the FPS of those things in our app, and etc. And we can come up with even more metrics. For example, we can think about layout shifts. So we have a lot of elements in the UI. Let's say, are they shifting in a way that our users don't expect to? This also leads to bad UX. So there are different metrics, and there are different ways to measure that. We can measure stuff in the laboratory, but we can also measure stuff in the field. And actually, it's really important that we think about measuring in the field, because that's the only way to truly know how it's going, how our app is doing. So it's like measuring with real users as they are using it. And to prove that, I have one really good example from the history. So does anyone here know this guy? Jonathan Nole. Yeah, we never hear about him. So he was the first guy to run the first experiment with real users back in 1746. And he gathered 200 monks, and he wired them with irons, and he discharged a battery. And to do that, he was doing that because he wanted to test the latency of electric signals in real users. And he happened to, by the way, discover osmosis by doing that. But the thing is, nowadays, we no longer need to do that. We don't need to discharge batteries in users. Browsers give us a a lot of APIs to measure and to optimize performance of those users. So that's what we're here for. And now we're going to discuss stuff that you might know, but I didn't until I had to handle these. And we'll start by talking about measuring with the web platform, with the APIs that the browser gives us. Ooh. To do that, I grouped in 4 different categories those APIs. We have first the general stuff. Some of these APIs are basis for the other APIs. We have timing APIs, which happen to be a lot of them. We have APIs for profiling, that is basically understanding what's happening with your code. And last but not least, we have some sensors. So in the general stuff, the first one I wanted to mention is the page visibility. That's also probably one of the most popular. And we can use this API either by accessing the current state doing document.hidden or document.visible state. And this is going to tell us whether the current tab is idle or not. And we can also register event listeners. And this is really handy because we can, for example, use that to cancel requests or other timing-based events. Or we can even optimize future experience. So we can start fetching media or something that's going to take a while to download when it's idle, or even chunks of our code when the tab is idle. And then once the user is back to the tab, it's going to have like a complete UI state. And you can also optimize by pausing like any media, so videos, carousels, anything the user is not consuming. And this is, for example, a way of optimizing their network. Another API, and this one is going to be the basis for more than half of this section, is the performance observer. So this thing, it basically allows us to listen to a lot of different performance events that we'll be discussing. And it does that by firing callbacks during idle periods in the browser. So, and you basically define which events you want to listen. You will see which events, but that's the overall syntax for that. So you instantiate a new performance observer, and then when you do observe, you pick which entry type you want to listen for. And the first application we see of the performance observer is the layout and stability API. So you've probably been in this place where you have either your website or your app, you have some elements shifting because you're fetching something from the internet, and once you fetch it, then boom, it shows up there, right? And there's some research around that basically proves that this is not good for the users. And we can use the observer and listen for the layout shift event. And basically, we can combine that with tools like web page tests. They have this film strip view thing. And you can get, for example, a full timeline of the layout shift events that happen. So this is, for example, in my personal web page. I was fetching my avatar image from somewhere else. And in the time I was fetching something, there's no intermediate state. So it was blank, and then boom, image, and then the task is pushed. And once you can spot those issues, you can, for example, address them by adding skeletons. So you've probably seen this on Instagram, Facebook. And there are a lot of libraries that are actually, for example, React Content Loader for people using React. So you can spot places where you have those layout shifts by using that API and add some intermediate state. Now the timing APIs. Because we had a lot of timing APIs, I split those in 2 different groups. So the first one is user, element, and event timing. So user timing is probably the easiest one. So basically it works by you defining some marks, and then you create deltas in between the start and end of those marks, and then you observe for these measures. And the first thing I like about that is that it plays really well with developer tools in the browser. So you're going to see a session called user timing, and that's how you can debug, for example, the duration of some specific operation that you decided to measure. And it plays really well with other tools like SpeedCurve. So in SpeedCurve, you can register your own marks, and then you can have, for example, a timeline of how that's evolving for the good and for the bad over time. The second thing is element timing. So as the name suggests, it has to do with the render time of the elements. And it's the basis for one metric that you've probably heard of in Lighthouse that's called LCP, or Largest Contentful Paint. And again, the API is really simple, so it's just one attribute that you add in your elements, like images or texts or anything that's, for example, critical for your experience that you want to measure the timing for that. And just like the previous one, it plays really well with tools, not only speed curve, but anything you use as observability tool for performance. You can track the evolution of how it's going over time. And last but not least, event timing. So this one, it's really interesting because it's the basis for the first input delay, and it's really helpful for tracking that kind of problem we discussed in the beginning. And it's really good, for example, for detecting the first input delay. So you can do observer that observe. So as you can see, always using performance observer. And then you can do your own math, for example, to get the duration in that. And there are a couple scenarios where that would be useful, mostly when we want to measure the latency. So let's say we have a table with a lot of content and etc., and we have a button that's going to reorder or apply some filter in that table. And we want to track the duration from the moment I clicked to the moment everything was reordered. That's one scenario. Or let's say we have a slider that's basically applying some filter to a dashboard or something like this. So. And I could be here all day, like thinking of scenarios where we want to track that kind of events. Now, this one is probably my favorite section, profiling, because like for me it was mind-blowing to see a lot of how much information we can get about our code as it's running on user's machine. So we have 3 APIs for that: long tasks API, the user agent specific memory, and the JS self-profiling API. So let's start with long tasks. So as probably you know, long tasks are those things that when we are profiling with DevTools and we see something tagged that's red, that's like something that's taking a lot of time from the main thread, these are all long tasks. And the long task API is going to basically report anything that's taking more than 50 milliseconds. And this is not a magical number. Actually, this number is coming from a model called Rail that is a user-centric model with a lot of guidelines for performance. And this one is the basis for both TTI and TBT metrics. And it's really useful for spotting not only long tasks, but also the side effect of long tasks, that is when the main thread is blocked. And it happens a lot. So, for example, when we have like working inputs that can be like text or checkbox or even links, if we have the main thread blocked by a long task, all of these things, they stop working. So it's really important that we spot these scenarios. And again, really simple. We just listen for this kind of entry, and what we get as a result is a lot of metadata about what was running for that long task. Not only the duration, but what triggered that, in what container it was running in, etc. The second one is the self-profiling API, and it's not a part of the performance observer. Basically, you instantiate a new profile, a new profiler, and then you start doing something that you, like any task that you think that's going to be heavy or that you're particularly interested in measuring. And then you get a full stack trace, just like as you would in developer tools. And with that stack trace, you can, for example, report it to another service or something. And as the name suggests, it's really handy for complex operations that you know they are complex, something that you're planning to offload something to a worker because you know it's heavy and you want to have better metrics. So that's one scenario. And it's also interesting because you can combine that with other metrics, like even business metrics, and then you can make correlations like, this is affecting the conversion rate of something, and et cetera, et cetera. And the last one is the user agent specific memory. So this one, if you heard about the JavaScript API before, this is kind of an improved version, and this is made so that you can track memory leaks. And it works by waiting for the garbage collection cycles of the browser, and if the garbage collection doesn't happen, then it forces it. And I love this one because we tend to overlook memory leaks in the browser. So there are many scenarios where they can happen. The first one, I think, is the most common one, I would say, when we just forget to unregister some eventlessness. But they might happen because of workers, or they even might happen because of when we have sparse arrays with a lot of objects. And there's a really good talk about that from the Chrome team about spotting memory leaks and addressing them in Google Chrome. But one exercise I would mention is this. So can you see what's the problem here, or where's, if there's any problem actually? I kind of spoiled, but so actually one better. Is B gonna be garbage collected? Yes or no? Like, yeah, so no, it's not, because that's how garbage collection works in the browser. It's by checking whether something is accessible, not it's being accessed, but because it can be accessible by object.b, then it won't be garbage collected. So here's a memory leak. And this API works like that, so you have the performance utility, and you can just measure user agent specific memory. It's a long one. And it gets really interesting when we put all these side by side and we figure out the amount of data we can have about our code, about what's running for our users. So I find that really, really helpful, especially if you work on apps that are managing like a lot of data. For example, this kind of sites was really helpful for me when I was working on an app that had a map that had 100,000 data points plotted to the UI. So there was like really CPU-bound stuff happening. Okay, so that's the second part of timing. So in this part, we have resource and navigation timing that are really related to each other. And then, last but not least, server timing that I kind of consider a way of front-end, back-end engineers helping front-end engineers help back-end engineers. You will see why. So for resource timing, again, we observe the resource entries, and we can use, for example, when we want to check if something was fulfilled via cache. So if you are doing caches in your app via service workers, for example, and there's one part that it's really important that it's coming from the cache, you can use that to properly debug and see if it's coming from the cache to users. And the navigation timing API is actually one API that gives you a lot of information about lookups, handshakes, redirect events, and any kind of things. And because it gives you so much information, it allows you to come up with really interesting metrics like the one we know as time to first byte. So we check by doing entry.responseStore when we are observing navigation events. And that's really useful for coming up with more meaningful metrics, like if we are using service workers, we can debug their startup times and the time it took for them to run, that kind of stuff, by also using the navigation API. The last one in this group is server timing. So basically, it's something that we can use to measure things happening on the server, like long tasks happening on the server. This could be, for example, some routing or some authentication happening for requests, or when we are querying databases or querying external services, whatever, anything that might take a long time in the server. We use this API via HTTP headers. So this is the syntax. We have like one metric, then we pass its duration and then some description. So as you can see, this is meant to be implemented on the server side. And then on the front end, what the front end engineers are going to see is this small thing when debugging using DevTools, for example, that you will see all of these metrics passed via HTTP headers. And why it's helpful is because when debugging something that's taking too long, you can spot exactly, oh, this thing on the server is taking too long. And then you can approach the backend engineer and say, hey, I noticed the problem might be here. So the person can, for example, debug exactly where it is. And we even have a lot of libraries that helps us integrating that in our server. Most of them are like middlewares. So we have middlewares for Node servers like Express, for PHP servers, for Java servers, etc. And then we get to the last session that are sensors. So here we only have battery and network. and but they are really, really helpful. So the first one is battery status. So it's a promise-based thing that you can just get the current info, and it's going to have, for example, the charge level or the time it's going to take for discharging the device, that kind of information. And you can also listen for some events, for example, if the phone is charging and that kind of thing. And that's really helpful because if you have something that is really heavy, maybe a game or something like this running in the browser, and you detect that the user is running low on battery, you can start optimizing on top of that, and then you can help users saving their battery. But my favorite one is network information. So that one is also really similar, and not promise-based, but really similar. And we can also register an event listener, and that's the kind of info we're going to get from that. So we first know whether this is a 2, 3, or 4G connection, but we also have information about the round-trip time, the time for downloading, and if on mobile, whether the user has the data saver mode enabled or not. And that's really, really amazing because we have like a world of possibilities out of this. We can, for example, my first one, and we'll have a demo for that, is when you switch like the definition of content you're serving. So if the person has 4G, you can serve like a full quality video, etc. But if they have 3G, you can start just serving the thumbnail, and if they click play, then you get the full video, that kind of thing. If you're preloading things, for example, in the idle, when the browser tab is idle, as we talked before, you can not do that if they are running on 2G connections, for example. You can defer a lot of things. You can also warn that they are downloading something. So this is common in apps like streaming apps where you click to download something so that you can use offline. They can detect you are on 2G, and then they warn you, are you sure you want to do that? You can also adapt your whole experience to scenarios where they are offline. And a lot of other things. For example, I've seen video calling apps. They detect that the person has 2G, and before they start doing the app, they just say, you better not do the app because the quality of the connection is so poor that it will basically be impossible to have that. And this is one example of using that in React. So you switch based on the connection type, and then if you have 4G, we render the full video. But if you have 3G, you render just the thumbnail with the high resolution. Or if you couldn't get, maybe it's 2G, you just render the low resolution thing. And actually, this idea is not new. Like this concept of connection where components has been there for a while now. And there are even hooks, libraries that brings, for example, hooks that allows you to do that. So this one, it brings hooks for detecting battery and network status. And you can do really powerful stuff like what Twitter does. So on mobile, when you enable the data saver mode and you are scrolling through the feed, it's going to just show the images in low resolution, and then you click the image, and then it's going to download the full resolution. So that's one example of using that one API. Ooh, was it live? So yeah, now that we saw some metrics that we can collect to reason about how our app is performing for our users, we can think about optimizing that or improving that. So the first thing are the resource hints. So probably you heard about some of them, but basically the whole idea of resource hints is thinking that if you can predict what the user is going to do, you can help the browser go one step ahead and optimize that. And we're going to see that. Usually the syntax for resource hints comes like this HTML attribute. So you can have pre-connect, preload, DNS prefetch, and pre-render. And you just add that, for example, to your font imports or CSS stuff or things like that. So one example is pre-connect. So pre-connect helps you cut a lot of latency in the route trips that are necessary, for example, when you are importing some other font, because it basically go ahead and tells the browser to set up these connections. So including the TCP handshakes, but also if you are on HTTPS, and you probably are, the TLS negotiations. So it's easier if we can visualize. So let's say we have this timeline, And we download our HTML, we download our CSS, and then we have or let's say we have 2 custom fonts. So they're gonna start loading here after we went through our CSS. And then we start doing all the networking for font 1 and for font 2. Using pre-connect, we can optimize that and push this. And of course, only after that they're gonna be rendered. Using pre-connect, we can push this to the very beginning because the browser is gonna go ahead of time and start doing the network part of that. And we have much more. So with DNS prefetch, for example, we are able to tell the browser about other domains. So let's say we are using a CDN for something that's out of our domain. That's one scenario. For prefetch, we can start fetching resources in the background, which is really helpful. So let's say we have an overall idea of the whole path of our app, and we know maybe by analytics that the users, after going to one route, they tend to navigate to another route. So if we have numbers showing that, we can, for example, start prefetching that one so that when they move, like a lot of things have already happened. And we can even have pre-render that is like one step further than prefetch, and not only we're gonna fetch, but we're gonna actually run the code in response to that. So that's really helpful, but at the same time, it's really important to remind that it's a gamble we are doing here. So we are spending users' network and users' processing time, for example, in the case of pre-render, for optimizing. So it's really important that we have metrics proving that it really pays off. Another thing are the priority hints. So basically, they are handy when you want to change, like to increase or to decrease the priority of something happening in your app. And there are some scenarios, for example, when you have non-critical data fetches, so you can lower the priority for that, and then you optimize the loading of what's important for you, for example. And one example of things that we might want to increase is the largest contentful paint image or hero, or let's say some really crucial part of the app that we want to increase the priority for that. We can also tag this to the browser. And we do so, again, with HTML attributes, so we have fetch priority that can be high or low. And we can use that in images or, for example, in scripts. So one scenario that's really helpful, for example, let's say we have a huge carousel or a huge list or whatever that displays a lot of images. We can just go high priority for the ones that the user are seeing, and then go low for the next ones. And the same things with scripts or third-party imports, that kind of thing. And the most amazing thing is that we can do that with fetch requests as well. So a lot of people don't know, but we have this config part of the fetch API, and we can pass priority low, and then we can defer some fetch requests that's not so important for that screen that the user is seeing. So this might be helpful. So let's say we have like a blog post, and then we render the blog post, and we don't want to have a huge priority for rendering the comment section. That's one example. Another amazing thing are responsive images. So there are studies by Google, for example, showing that when you have like the desktop images on mobile, they can be like 2 to 4 times larger than what you needed for a tablet or mobile phone resolution. And we have this source set attribute that basically we can use to save bandwidth. So it works like this. It doesn't replace the source attribute, but it's an extra thing that is source set, and then you pass different versions of the image, and you can filter then, for example, by a given pixel ratio or something, and then by doing this, you will be like saving a lot of bandwidth, especially on not so powerful connections. Native lazy loading. So again, another simple attribute as we saw on the previous session. So you can pass loading equals to lazy, and you can do that to both images and iframes, and there are even studies proving how doing that on iframes optimizes both FCP and FID of a lot of apps. And I myself, in the previous app I was working, where we allowed users to manually add iframes to the app and etc. When we started like lazy loading iframes, was really amazing. The last one here is the native scheduler, and I don't have a lot of time to approach that, but it's like one of my favorite things happening on the web. So basically, we do have a few scheduling primitives already. So we have set timeout and set immediate. We have request animation frame. We have request idle callback. And if we're doing workers, we even have post message, which is a scheduling mechanism in a sense. But the thing is, if you ever had to do any complex logic with scheduling things, or if you had to implement a custom scheduler, or for example, do anything that is like not, that's more deep into React scheduler, you see that all of these APIs, they are not uniform, and they could be better. And people are aware of that, and that's why we have this prioritized task scheduling API. And actually, this is going to bring a lot of promise-based primitives that are integrated into event loop, including post tasks or primitives for yielding, or even primitives to figure out whether there's some input happening at the moment that you can, for example, yield back to the event loop and optimize some response to that. And actually, we have companies already using them. So Airbnb, they have a really interesting case on how they are using the post task thing, or Facebook, for example, they are the ones who implemented the input pending, and they are using it a lot. And there are even libraries that are not like polyfills or anything like this, but are inspired by the spec of the native scheduler. So it's really, really amazing what they're doing with that. And I know like it's a lot of things, and I myself, every time I figure out about one of these APIs, it's always mind-blowing for me. But there's even more stuff out there. So there are things we can do with CSS, for example. We can do like font display swap to optimize how our fonts are loaded for users. We can do will change to optimize animations and transitions. We can use APIs like intersection observer to dynamic load something only when it's visible to the user. Or if we have like heavy processing happening on canvas, we can have off-screen canvas on some browsers, and much, much more. So there's Quick, there's more of the HTTP free spec, so you can reduce a lot of the round trips you have communicating with the server with Quick. And there's even HSTS, that is a way of reducing the number of redirects. So you know when you do HTTP and then you go to a page, and then that page has HTTPS, so you end up redirected to the HTTPS version of that. So yeah, you can use HSTS to reduce the latency even in that. But I love this talk. It says, "You're not Facebook." So the title of the talk is that, and it's basically about over-engineering things. And it's not like we're implementing schedulers or optimizing with all of these things, or collecting all of these metrics, or even implementing our own custom analytics on a daily basis. We have services for that. We have things like Calibre or Speed Curve as observability services for performance. We have libraries like Web Vitals that, for example, Web Vitals by Google, it comes out of the box and creates React app. And depending on which platform you're using, Vercel, for example, they have their analytics services with a lot of these metrics integrated out of the box. So what I would say is, if you're interested in that, it's overall safe to start with those observability services, or maybe a library like Web Vitals. And then if you miss some metric, if you figure out another metric is important to your app, then you create your own abstractions on top of the specs we saw. So this abstraction can be, for example, a custom React hook, like the one we saw for getting network information. One of the last things I want to discuss is how to keep up with all of these technologies. So, for example, if we check the compatibility table of some of them, we'll see that they're not available everywhere. We might see that some of them are not available in Safari or Firefox, for example. So I wanted to kind of share with you my strategy for these scenarios. So here's a sample app that is basically rendering videos of talks, and I am going to combine that with this library that it's really alpha, so don't use that in production, but it's a library for doing pattern matching React. So basically we have video and preview components, and we are lazy loading them, and we are using use network status to get network information. And this use pattern match comes from the library. And here we have different cases. So we are handling cases where the API is not supported by the browser, but also cases where it's 2G, 3G, and 4G, like not the full code is there. So what happens is if we are in Safari where it's not supported, the user is going to see, for example, network detection not supported, and we want to play it safe, so we render the full video. But if we are in Chrome and it's supported, you're going to see 4G connection supported, and you render the video. And if we start, for example, emulating a 3G connection, you're going to see that only the image was rendered, and then you see 3G connection. And this is really great, but the other great thing about it is when you check the networking tab. So when you had 3G, you can see that only the preview chunk was downloaded. And where you had 4G and no throttling, you can see that only the full video chunk was downloaded. So for the other users, the whole YouTube by frame, for example, was never there. Whew. So basically, going back to why we are here because we build apps that runs in browsers, and we don't usually think a lot about the browsers that are going to be running our apps. So do you guys happen to question a lot where your app is running? Okay. So I did that recently, and I started checking, like, first the top 10 browsers that were opening the app I was working on. So yeah, pretty normal, I would say. So Chrome, first iOS, but then Chrome, Edge, Safari, Firefox, and you can even see Internet Explorer there. But it's really interesting when you start digging more that, because, for example, I started seeing something like BlackBerries and Nokia browsers, and Samsung, like those old Samsung devices that they were running their own browsers, and even PlayStation. So I figured out that my app was being used on PlayStation browsers. So there's a lot of browsers out there, and it's crazy to think about all of them. And even social networks nowadays, they are browsers, and they have you have LinkedIn browser, Facebook browser, Instagram browser. All of these are in-app browsers that have a huge market share. These browsers, they run on devices, and they are subject to different connections. And for me, it was kind of a reality check to see, for example, that on mobile, the slow first input delay was happening 7 times more than on desktop. And not only that, but it's also another reality check to see that there are many parts of the globe where 2G and 3G still have a huge share of the market, even more than 4G or 5G, for example. And not only that, but also the fact that having 4G or LTE connection doesn't mean necessarily being fast. So the speed of the LTE connection across the globe changes a lot. So even if you have 4G, it doesn't mean it's necessarily fast. And all these things are used by people. So, and people say that speed, or in this case, how long it takes to load, is the most important thing. And for me, it was another reality check to figure out that it was even more important that whether they could find what they're looking for. They really cared more about loading fast. And when you start seeing metrics about people and etc., you find really crazy stuff. So there was this research, for example, from more than a decade ago, that it figured out that 40% of British people, they really assaulted their computers because they couldn't get what they want. And there's a similar research for American people as well. And then fast forward in time, you find another things like, for example, how much a delay results in frustration, and then this decreases engagement. And again, moving in time, this one is one of my favorite ones, for example, because they literally attached devices measuring people's heart rates, and they figured out that those delays were equivalent to the anxiety of watching a horror movie. So that's how bad performance impacts people. And they feel so impacted that they do abandon sites or apps because of those loading metrics and that kind of stuff. And all of these, they do drive businesses. So, for example, there's research showing how long tasks delay TTIs and other stuff. And it decreases a lot the overall conversion rate. And in mobile, it was 12 times worse. So that's really crazy. And when you see this on a chart, it's even more crazy. So this is conversion rate going as the first page TTI increased. So some closing notes, finally. I would say that it's really important that we always try to correlate all of the cool metrics we saw with actual business metrics. So because we cannot game these, because a lot of metrics, especially for us front-enders, is about tweeting and showing off, hey, it's downloading, it's loading in this amount of milliseconds and etc. But if we correlate that with business metrics like conversion rate, then there's no way to game that. The second thing is, it's a bad idea. In general, it's a bad idea to assume people are going to have fast networks and really powerful devices, and etc. And because of that, it's also important to test on real connection in real phones, because we tend to assume people are going to be using iPhones and that kind of thing, and that it doesn't happen so often. Another thing is to avoid observer effect. So we tend to see a lot of cool metrics and start gathering them to the point that just by collecting a lot of metrics, we are actually making performance poorer because we have a lot of code to collect those metrics. So it's also important that we balance that, and it's important that we get rid of the noise. So when we start tracking real users, we will also have bots and that kind of thing. So it's important that we filter it out of our metrics. It's important to think that the cliche that there's no silver bullet. So, and that's true, there's no silver bullet, both for metrics and for optimizing on top of metrics. So it's important that you identify what's relevant for your app. Another closing thought is that we are hiring at Medallia. So if you want to work with performance and other cool stuff, reach out. The slides for this session are available on my speaker deck profile. So if you want to check it out, go for it. If you like that kind of topic, I have other sessions about performance and internals of things and that kind of stuff. This is the go-to link for all of that, or for more info about Medallia. Probably the most important thing of the session is I have stickers. So if you're interested and if you have questions or you want to share your experience about performance, reach out. And that's all I had for today. Thank you so much.